screw has a diameter 32 mm, a pitch of 4 mm with double threads and is to be used in a press. The given data includes the coefficient of friction for collar as well as for screw threads is 0.07 and collar diameter is 40 mm and force to be raised is equal to 6.4 kN per screw. Find the torque required to rotate the screw against this load. Here the options are 20.92 Nm, 22.92 Nm, 23.92 and 17.92. Here, coming to the solution, the total torque required to rotate the screw against this load is given by, let us say T is equal to Ftm by 2 L plus pi mu dm by pi dm minus mu L plus F into mu C dc by 2. This is the total torque required to raise this load. Here F is given by the load to be raised, which is equal to 6.4 kilonewton, and here mean diameter can be calculated by using the diameter minus p by 2, that is major diameter minus p by 2, which is equal to 32 minus p is 4 and 4 by 2, which is equal to 30 mm, and the length of the screw is equal to n into p, and it is a double screw threaded, so 2 into 4, which is equal to 8 mm. This is the length of the thread. So now substitute all these values in the equation torque, which is equal to T is equal to 6.4 into 30 by 2 into 8 plus pi into 0.07 30 by pi into 30 minus 0.07 into 8 plus 6.4 into 0.07 into 14 by 2. So which is equal to 23.92 Newton meter. So here the right answer is 23.92, and in the option the correct option is C. C is the right answer. A cone clutch has a cone angle 11.5 degrees, a mean frictional diameter of 320 mm and a face width of 60 mm. The clutch is to transmit a torque of 200 Nm. The coefficient of friction is 0.26. Find the intensity of pressure by using the assumption of uniform pressure. Here the options are 0.4 megapascal, 0.6, 0.8 megapascal and 0.9 megapascal. Here the intensity of pressure can be calculated by using the normal load acting on the clutch, that is equal to P into 2 pi R into B. Okay, where R is the mean diameter and B is the face width. Here and normal load is given by W into cosecant alpha, which is equal to P into 2 pi R B, where alpha is the half cone angle and is given as 11.5 degrees, and here the pressure is equal to W cosecant alpha by 2 pi RB. First we will have to find out this load. This load can be obtained from the equation the torque, that is 2/3 mu W into R1 cube minus R2 cube by R1 square minus R2 square, where R1 is the outer radius and R2 is the inner radius of the clutch. And here, but we don't know the outer radius and inner radius of the clutch, we'll have to find out by using the mean radius, that is R1 is equal to R plus B by 2 sin alpha, where R is the mean radius of the clutch, so which is equal to 320 plus, and B is given by 60 by 2, and alpha is the cone angle and is equal to 11.5 and is nearly equal to 166 mm. So in the same way, the inner radius of the clutch is given by R minus B by 2 sin alpha, which is nearly equal to 154 mm. Now substitute all these values in the equation torque, and here mu is the coefficient of friction and is given by 0.26. So by using all these, we can calculate W. Instead all these values, that is 200 into 10 cube, where torque transmitted by the clutch is 200 Newton meter, and is equal to 2/3.26 into W into 166 cube, 154 cube by 166 square minus 154 square. So use value of W and is equal to 4805 newtons. Now substitute this value in the pressure equation, that is W into cosecant alpha by 2 pi RB. From this we can get here it is equal to 4805 into cosecant 11.5 pi 2 pi into 150 into 60. So it gives a value of nearly 0.4 Newton per mm square or 0.4 megapascal. So here the right answer is 0.4, and in the option the correct option is A. A is the right answer. Easier to predict the performance of a large centrifugal pump from that of a scale model 1/4 the diameter. The model absorbs 20 HP when pumping under test head of 20 meters at its best speed of 400 rpm. The large pump is required to pump against 60 meter head. The speed of the pump will be. So here the options are 100 rpm, 153 rpm, 167 rpm and 173 rpm. So here, coming to the solution, the tangential speed of the turbine is given by pi dn by 60, but this tangential speed is directly proportional to square root of head available, isn't it? So from these two equations, one can be obtained, that is dn by root h, which is equal to constant. Now consider for the model as well as for the original pump this constant, which gives dn by root h of model is equal to dn by root h of the pump, that is the actual pump. So by using these two equations, here the diameter of the pump is equal to 4 times the model, or the diameter of the model, which is 1/4 of the diameter of the pump. So that we can write here, let us say d is equal to diameter of the model, so that 4d is the diameter of the pump, and speed is given by 400 rpm for model, and head available is equal to 20 meters. So which is equal to 4 times the diameter of the model into n by, and head available for the pump is 60. So from this equation we get here n is equal 173 rpm. So here the right answer is 173 rpm, and in the option the correct option is D. D is the right answer. Ratio of average velocity to maximum velocity for steady laminar flow in circular pipe is. The options are 1, 2, 1 by 2, 2 by 3. So here the maximum velocity in a circular pipe when the fluid flows through the pipe is given by 1 by 4 mu dou p by dou x r square, and the average velocity for the same type of flow through a circular pipe is given by 1 by 8 mu dou p by dou x r square. So here the ratio of average velocity to maximum velocity is given by, it is 1 by 4 by 1 by, sorry, it is 1 by 8 by 1 by 4, and which gives 0.5 is equal to 0.5 or 1 by 2. So here in the option the right answer is C. C is the right answer.